All right, so this video should become mostly straightforward examples and then with a little twist. And then the next video should be some messier examples with some more twists. By the end, you should be ready to play some Twister or something. Let's go to example 2, everyone. Oh, as a quick interruption, I do want to comment that I'm not a big like step-by-step instructions kind of guy, and I don't do it a lot in my classes. But in section 1.5, the book does have this problem-solving strategy, which I'm talking through when I'm doing these problems, but I'm not writing out, hey, 1, 2, 3, 4, 5, do this. This is very helpful for a lot of people. If you're lost, or if this is kind of the way that you think, if you want to have a list and say, okay, let's go down 1, 2, 3, 4, 5. Please copy this down into your notes or refer to it during your homework, okay? Let's do example 2. Evaluate. Part A, going to be the integral of 6x times 3x squared plus 4 to the 4th, which should look pretty similar to our last example. Again, we can't just integrate as it is. We can't integrate just as it is because we have one function being multiplied by another function, and multiplication of functions doesn't really work easily for derivatives or for integrals. As a side note, I said that substitution is basically the flip side of the chain rule. So it's not the flip side of the product rule, even though we have a product here that we're trying to take care of. The analog or the correlating thing for product rules we get into later. So we don't know how to do this integral, but we say we have a chain rule kind of situation here. We have an inside function. And so specifically, if we look at this inside function, we have something on the outside that it's derivative. The derivative of that inside function is that 6x. So this is prime real estate for planting a use substitution. The metaphors are really, they're going somewhere today. So let's guess that this is u. We don't know, but we're guessing. Inside function a lot of times is going to be u. As we do more in these videos, more of these problems, we'll talk about other things to kind of spot. But let's say, okay, if this is u, what happens? And especially if you're lost or confused on harder problems, don't feel the need to know what u is. Just try something. Maybe you spend 3 minutes and it doesn't work, but you make progress. And you might learn something from the mistake. You try it and see, oh, this didn't work, but I see kind of what happened. You get to understand the problem a little bit better sometimes. So du dx, the derivative is just 6x, which is great. And that tells us that our du is 6x times dx. And that's perfect for us because it lines up. So this blue together, it's not written next to each other, but it's multiplication. Multiplication is commutative. We can switch the order of multiplication. This is our du. And now we can substitute. All right, that didn't work. And we get that we have u to the 4th du. Right? Because this is just u to the 4th. And the blue stuff is exactly du. And that's what tells us we chose correctly, because we can integrate this. Just the power rule, add an exponent, divide by that new exponent, add c, and then substitute back. U was 3x squared plus 4 to the 5th. I'm not going to check my answer on this one because it's so similar to the one in the last video, but you could take the derivative of this guy and you should get that because of the chain rule. All right, let's do another one, part B. The integral of z can be another variable, that's fine, times the square root of z squared minus 5. So we're going to approach this very similar to before, where, okay, we see an inside function here, something on the inside. So what if that's our u? Yeah. So this isn't quite as nice as the last one. Because this is not the derivative of the inside. It's close. The derivative of the inside is 2z. It's close, but it's not quite there. Well, there's two ways of dealing with that. You can either just make it the derivative of the inside, but that's lying. But now I'm not lying anymore. We can do this. Multiply by 2 and divide by 2. Yeah, that's just multiplying by 1. We do that all the time when simplifying fractions. And constants can come out in front or go inside integrals, no problem. So we could write it like this. This is usually a straightforward and quick, no, not straightforward. This is usually a quick method that I find a lot of times is less straightforward and a little bit more confusing. So I'm going to show another method of evaluating these integrals. Let's let u be z squared minus 5. So du dx is 2z. So something that helps a lot of people is instead of just solving, oh, sorry, there's a problem here. Pause the video, try to find the problem is what I'd recommend. We're not taking the derivative with respect to x. That would be silly. We're taking the derivative with respect to z. So du is 2z dz. Now again, you can do that first method of say, oh, all we need is a 2. And we can balance that by multiplying by 1/2 as well. We're multiplying by 1, just like when we're adding fractions together to get a common denominator. Another thing that you can do is you can actually just divide both sides by 2z here. What happens if we solve for dz? You can totally do this. And I think this is more straightforward for a lot of people. You can do this for every substitution problem. Even for this substitution problem, part A. If you just solve for dz or dx, I think it becomes a lot more straightforward more of the time. So when I don't have the derivative being exactly there, most of the time, I'll take an extra step and I'll solve for whatever we have here. Because then let's look at what happens. It's a little bit weirder of a method, but I do think it makes things easier in the long run. So the z, that's nothing yet. We're just going to leave the z alone for now. But dz, we know is this. So we'll be able to substitute that out. We have the square root of u. We'll keep it like that. And then again, we know dz is du divided by 2z. And now we get cancellation. The z cancels with the z. And we're left with the integral of the square root of u. I'm going to write the square root of u as u to the 1/2 power times du over 2, which we can also write as 1/2 times du. Dividing by 2 is the same as multiplying by 1/2. And now we can factor this guy out. Constants that are being multiplied can come out in front of integrals. So we get 1/2 the integral of u to the 1/2 du. And now we can evaluate the integral. And again, you could have achieved the same result quicker, but maybe more confusingly, depending on what your perspective is, by just saying, well, I needed a 2, so let's balance it with a 1/2 right off the bat. You could have done that. A lot of people do that. There's really kind of two methods for this. I think this method takes a little longer, is a little messier, but it's more straightforward. And so it's more replicatable, more useful for a variety of problems. But they're both fine. Now we take the antiderivative by adding an exponent and dividing by that new exponent. Dividing by 3/2 is multiplying by 2/3. Then we add c. We simplify to get 1/3 and substitute back in what u was. U was z squared minus 5. And we get this as our final answer. And if we're good math students, we check our answer. Oh, wait, there was a missed opportunity right there. We check our answers by saying, what's the derivative of this with respect to z? We should get back the original integrand. So if we take this derivative, we get the power rule. The 3/2 comes down in front. The inside stays the same. We subtract 1 from the top, and the derivative of any constant is 0. That looks like a C. It's a 0, I promise. But I kind of wrote off of the screen. All right, it still kind of looks like, is it more like a 0 now? And again, we get some cancellation. And oh, I forgot something. I didn't use the chain rule. We need to multiply by the derivative of the inside, which is 2z. We get more cancellation. And we're just left with the square root of z squared minus 5 times z. And hopefully, that's what we had. And it is. The integrand of the original problem should be what happens when you take the derivative of our final answer. That's basically what this section is. Next video, we'll cover some trickier examples and some other things that can pop up. And then we'll introduce how to do substitutions for definite integrals. And then I'm just going to do more problems to give you more practice after that. All right. Good luck. Let me know if you have questions.